All right, so today we're going to talk about creating SQL databases. As I was mentioning right before the recording started, there's a couple softwares that could be helpful for when you're dealing with SQL databases because they are so opaque. You can't just like open them up in like your Excel. So as I had just mentioned before I started the recording, there's one called Mysql Workbench. These are both free, so you can download. I will say I had issues downloading this one, but I have it on like my other computer and it works fine. It might be a work computer thing, I don't know. But on this computer, I have dbeaver. And this is actually a database that I created on AWS, which is a process I'm going to walk through in a little bit. And all I had to do is link up like the AWS details and it can take a look at all the tables within my database. So we're going to play around with this in a little bit as well. So highly recommend that you use one of these. It's not necessary. I mean, if you're confident in, I like to use this to just confirm that I've created my tables or like my data got inserted correctly. So yeah. The other like additional thing I wanted to talk about is creating your schemas. So there's this one website called DB Diagram that I've used, and basically it allows you to create this for your own database. If you have a SQL database that you're going to create, it's a very, very good idea to have this so that you yourself can remember, what information is in which table, but also for like jobs that require some database knowledge, being able to work and create your own schema is very, very useful as well. I will say I'm actually taking a database course currently, and it's all about reading these diagrams. So you can see here there's like a different language. It's not really in like Python or anything, but it's pretty easy to pick up. They, I believe, have some templates that you can just go off to create your own schema. But yeah, this is all like other parts of dealing with databases that don't even include creating the database itself. Any questions about any of these before we get into actually creating our SQL tables?
And these are all about relational databases or something like unstructured databases like MongoDB or something?
These are all for relational databases. If you want to use Mongo, feel free to use Mongo. I believe like the code that I have in that notebook back in phase 1 actually is the code that you can run something on Mongo. So yeah, that is, Ali, you're right in saying like those are unstructured. MongoDB, if anyone remembers, it's more of like a dictionary format of data where like, you don't have constant columns. You basically can get around that with like your different keys and values. Whereas these are more for tables, anything that comes in like a table or data frame format. Anything else? All right, so hopefully this all got uploaded onto the repo correctly, but as a quick, to use as our quick examples, I took these tables, I put 4 here, but we're only gonna use these 2 because you can repeat the same processes. But I took these from one of the SQL labs. I actually took the SQL tables, converted them into CSVs, and then we're just gonna put these back into SQL databases. There's going to be 2 methods I'm going to talk about. A toSQL method, which is the easiest method. You can see that it's really just these lines. And then after that, I'll talk about AWS. And yeah. So to start, we're going to start with a customer table as well as let's do this order details table. I think I'm only going to put in, yeah, these 2. So if you have your data read in and you just want to dump it into SQL, the fastest way to do so is by using the pandas built-in toSQL method. And you can see that, hold on, let me just make sure my full screen is sharing because we don't need any of that anymore. There we go. All right. So here you can see that the things that I'm importing, I'm using this create engine from SQL Alchemy. SQL Alchemy is actually a completely different thing, but it has this create engine method or create engine functionality that we'll use to create our database. Couple things to note. This is your database file. Sales.db is what I'm just going to call it. And then if you want to create it in the SQLite format, you just have to start with this SQLite with a colon and 3 slashes. I believe if you use like 2 or 4 slashes, I honestly forget, you would put like your absolute path, but that's something you can find from the documentation. This echo equals to true is similar to using verbose in any of like the scikit things. So echo equals to true, you'll see that when I run any sort of function, there will be some output saying what's going on. So actually most people like to have echo equals to false, but for our purposes, I think it's useful to see echo equals to true. So to start, we're just going to create this engine and that runs. Let me actually bring up my Jupyter homepage so you can see the database being created. So right now I've run that, but I have no database here. You could technically put it in a data folder as well, but the database has not been created because I haven't put anything in it yet. So this SQL table creation is really just one line. It's really just this df.toSQL. So I just threw it into a function just so I could do it on multiple tables. Data frame is going to take up, it's going to take in the actual data frame that you want to turn into a SQL table. You're going to name your table. So when you query the table, this will be the name of the table that you're querying. And then you have to feed it in the engine as well. So you can see here when I'm doing the df.toSQL, I'll have the table name. This is the df that's going to be turned into the SQL table, give it the engine, and also if it exists, replace. So basically, if, for example, for some reason, if I rerun this entire notebook and I don't want to have like duplicate tables, I can just have it replace. Another argument they can put is append. So sometimes if you, for example, collect more rows of your data, you can technically add to that SQL table by doing if exists equals append. So yeah, if I run this, this is just a function. And as our first example, I'm going to throw the customers table in. By the way, the customers table looks like this. It's a fair, I think it has 13 columns if I remember correctly. I can just create that SQL table like that. And you see that all of this one line is doing all of the SQL stuff. So this, if anyone is familiar with SQL, this is the SQL syntax for actually creating a table. And yeah, this is the info that it is throwing in as well. So if you don't have echo, nothing would get output here. So some people like to see this, some people don't, really up to you. So yeah, any questions at this point? All right, so let's just do the same thing with our order details table. The same thing will pop up. You can see that for order details, we have index, order number, product code, so on and so forth. And that is on there. And then just like that, I have 2 tables in my SQL database. Just one quick thing to remember, the database is called sales. So now I can literally just query from my SQL database. Of course, if you have more tables, you can do like complex join statements, whatever your SQL queries are. But just like that, I can query my data just like this. Cool. I believe you see here that the index exists here. Oh, and something else I wanted to show you. I'll show you all in a little bit. If you don't want this index, I believe it's like within toSQL, you can do like a index equals to false. But yeah, the one other thing I forgot to show you all is that now this database file exists here as sales.db. One trick that I like to do if I like create, if I don't like the tables that I created, I'll just delete the database and then just reinsert my tables using this method. But yeah, this is the most straightforward way to do it. Any questions before I move on to like the more complicated AWS way? All right, let me just have this here for later. All right, so AWS has a lot of products. If anyone has ever looked at an AWS page, there's a lot going on. Actually, I can show you all here. Within services, all of these are products that engineers could potentially use. And the specific one that we're going to use is RDS, which stands for relational database system. So relational database system is basically SQL tables. I've linked here. Oh, before I get into that, this database just lives on AWS. You can actually do all of these same commands on a local database if you want to be more specific with like things like data types. So pros and cons of using this versus the method I talked about earlier. If you're using something like this, you can configure your database more professionally. So for example, you can really coerce that, all right, the data type in this column must be an integer, or the data type in this column must be like a string with characters no more than like 64 characters. So you can actually configure that a lot more like professionally. I would say that at this stage, not like we as data science bootcamp grads don't need that level of like precision in deciding on like your database configuration, but good to practice. Some cons you'll see here that is a very, very manual process. Like, whereas this immediately through the toSQL method, it automatically generated these SQL queries. We actually have to write out all of these SQL queries where we're creating the table and doing all the other stuff, which you'll see. Now, to set up your database on AWS, there is a really, really nice walkthrough, which I'm not going to go over because this just has you configure your database. The instructions are super, super clear. I actually just did this yesterday, so I know all the instructions work. Very, very important that you read every step, because if you do something incorrectly, you might not be able to successfully connect to your database. So make sure you read this very, very clearly as you're setting it up. And basically, when you're done setting it up, you'll get something like this. You'll have your database here, and my database is DB1. So from here, all of this was automatically configured. I did not do anything. The only things that I had to add are my database name and a password. And that is done under modify, or it actually, you can do it as you're setting up. It's in the steps as well. So I'm not going to go too in depth into that. But anyways, this is my database that lives on AWS. This is also free, I believe, until you get to, let me see. Yeah, I think as part of like the free tier, I apparently get 100 terabytes. I don't think that is correct. But yeah, one thing that I'm going to tell you all as well as you are finishing out your capstones, if you're using this, you can actually shut down your database just so you don't get charged. So one annoying thing is Amazon is pretty opaque about their pricing. So I actually, on my first AWS account, I actually got a bill for like a couple $100 because I didn't shut down my database and something was being executed and I had to pay for it. And so I did not do that. So be careful about that. But I will say learning how to work with something from AWS is very, very valuable. But anyways, back to my databases. All right, we'll refer back to this now and again. So after you set everything up within AWS, we got to set some things up on the Jupyter Notebook side. And what we're going to use is we're going to use the Mysql connectors. And so I'm just going to import that. You might also have the pip install. You probably have the pip install that as well. So I have that there for you all. And then this is the step that has you connect with your database. So within mysql.connector, and this, remember, we haven't created any tables yet. So you're just connecting to like, you haven't even created a database. You're just connecting to the cloud at this point. So this is the host, and this is my username and password that I created, but this host name, make sure you copy it exactly, comes from this. This is the endpoint. The port you may or may not have to add because most remote ports have 3306 as a port, so you don't have to worry about that, I think. But yeah, just with this information, we can interact with the database. So we have our connection and our cursor. So that's done. Really quickly, because I have already created a database when I was putting this together, I'm just going to drop my database so that we can start from scratch. Actually, one thing that I can, actually, no, I'll show you all that later. All right, so, other things that you can see through this console is, where is it? In monitoring, you can see how many connections there are. So apparently, well, I know that now there are 2 connections to this database. There is one through my notebook, and also I have my like dbeaver is set up to this as well. So I do have 2 connections. So yeah, this is just a cool thing to see, I guess. All right, so several steps that we're going to have to walk through in creating our database. First, you have to create the actual database. So not the tables, but the database. So I have all of this code for you here so that you don't have to write it yourself. I'm creating the database called sales. And I'm basically executing a create database line in SQL. This is just error messages that'll pop up if something goes wrong. So if I just run this, that has been created. And then, oh, sorry, this is just the function to do so. And then this actually creates the database. So you can see that the database still does not exist as of now. So first it's going to look for if there is a database, and then it creates a database if it doesn't exist. One other thing to note, I'm closing the connection after the database was created. You can sort of think of that as like saving before you exit. I like to do that just so, I don't know, it's kind of like a peace of mind thing for me at least. I just like to close my cursor, then you'll see I reopen them whenever I want to make a change to my database. Any questions at this point? All right. So we've created the database, but now it doesn't have any tables in them. And for SQL tables, I forget if your labs walked through creating the SQL table manually, but creating SQL tables, you have to do it, in this case, manually. And to start by, when you want to start creating a table, you have to first tell it the schema of your table. So in this case, like, what are the columns in each table, and also what are the data types to expect within each column. So this is kind of an annoying thing to do, but I had to type this all manually. Creating this table, customers with these 13 columns. And for each column, I have to give it the name, what the data type is, and basically the numbers in the parentheses are how long of an input it accepts. So here I can give it any integer up to 11 digits. Varchar is variable characters, I think. So this is basically a string of up to 64 characters. I think those are the only ones. You can do floats as well. And not null just makes sure that it's not a null value. So basically this is the create table part. You see that this is actually a multi-line string. You have to do it in this format. I'm honestly not sure why. It doesn't work if I do like the triple quotes. I actually did test that out yesterday and it didn't work. So this is the format that I had to have it in. And this multi-line string exists in a set of parentheses. This other thing with engine equals to InnoDB, I'm going to be honest, I don't know what that is either, but it has something to do with the way you create the database, I think. But I personally don't know what that is. I just know you have to have it there. So yeah, so this is just what I'm doing here is I have a dictionary called tables. And if I had multiple tables, I'm not going to create multiple tables. So I did not want to type all of this out. So you can see how this can become a very tedious process. But basically, if I had multiple tables, I would just put all of the information into a dictionary that I can then loop over. So also, I was using the customer's head to just make sure that the data would match up here. So for example, a customer number wouldn't go more than 11 digits. None of these names would be more than 64 or 16 characters. So this is something that you're going to have to cross-check in your data cleaning process. These are things that you have to look out for. All right, then if you take a look at what customers is, the create customers table command is, this is what it looks like. So because I closed the connection earlier, I'm going to have to reopen the connection to create my tables. So before I do that, I'll just walk through the code. So this is just a new connection. The new thing that we have here is because I've already created this sales database, I can now hook it up to the specific database within my within my cloud, I guess. So what I'm doing here is I'm looping through all of the tables and I'm basically going to execute I'm going to execute the create table command. If it already exists, it'll say it already exists. If not, it'll say it's okay. So let's just quickly do that. And awesome, our customers table has already been created. Any questions at this point? Feel free to just copy and paste this code. A lot of this was also not written by me. I think it's in a lot of the guides, they actually use the same language. So I think it's fine. Any questions at this point?
Excuse me, Ish. I'm probably asking this because I have no experience with databases and SQL servers.
All good.
But why would we want to have our data saved in SQL servers instead of in data frame?
I would say for this project, it's more to have a SQL component in your project. SQL databases are more memory efficient than data frames or CSVs. So a SQL database is usually a lot smaller than like your CSV files with the same data in it. Also, SQL, as a database, you have the relational element that you don't have with data frames. You would have to do the join with two separate data frames, whereas you can, I don't know. I feel like if you have a lot of data in multiple tables, SQL is a good idea to go. But honestly, for this project, I think not too many of you will be working with a lot of tables. So students usually use this as just a way to incorporate some SQL into their project, just so you can say that you have some experience creating tables and working with SQL.
Okay, thank you.
You're welcome. Anything else? All right. So,
and
yeah.
we have to maintain our connection between those tables while we are working with them, or just one connection is enough?
Yeah, so I personally like to always have, well, you don't have to maintain the connection. Basically, only if you want to get more data, then you have to open up a connection. But once you've gotten the data, you can close your connection because then you would have it in your notebook already. You will see that, especially if you're working with AWS, the connection does time out. So if I had run this and then went to explaining this, I might have had to just rerun this cell again. So on AWS, I know the connection times out. I don't know what is the time amount. I think honestly, more than a couple minutes, you would have to rerun it. Just because they don't want to keep connections open all the time. I don't know what the reason is for that, but I know that that's a thing.
Okay, thank you.
All right. So now we have our database. We have an empty table. The next step, which was one of the more annoying steps, is inserting your data. Inserting your data can be very, very finicky. You have to be very precise with the command that you're writing. I ran into a lot of trial and error, but I found that this is the more standard way to do it. So usually if I'm inserting data, I like to just take a look at the columns because this is what you're going to have to do. So some of you might have come across this in the past, but this is an older method of string interpolation. So, now we have F strings, now we have the dot format strings. Doing the %s was one of the older ways of string interpolation, which I found that is one of the more standard ways for doing it in Python, which is kind of old fashioned, but sure, whatever. Basically, the command to insert data into a SQL table is literally just insert into table name. In parentheses, you have to list out all of the columns of which you want to insert data into. And then you're inserting these values, and then you have to have the same number of values there. So the way that the Mysql connector does this for you, you have to set it up this way with the string interpolation, like %s's. The %s's just means that basically here I have 13% s's. I'll have 13 inputs and they'll just match up. So we just take a look at what this looks like. It literally looks like this. The next thing I'm going to do, I'm just going to do some really quick cleaning. Another thing that I found was that I had to convert everything into a string because SQL commands are in strings anyways. So I just converted everything into a string. I dropped all my null values really quickly because I didn't want to deal with this for this, but you would ideally deal with all of your data cleaning before throwing your data into SQL. And you'll see here, everything is a string. So even these numbers are strings. So as you can see here, I had a few like floats that I had to convert into integers. And then I converted everything into string in its right format. The next thing you have to do is put it into a tuple. So the way that you can get this information to interact with this statement is having every row as a tuple with its values. So as an example, the first one looks like this. So the first thing that we're going to insert is this first row. We're going to have it in this format. So this is really important. You can just coerce things into a tuple by taking the values. I'm just going to insert one first, and then I'll show you all how I insert everything at once. So in this next cell, I have the insert statement. Here you can see I'm opening the connection again, creating my cursor again, and this is the insert. It's just cursor.execute. Within the cursor, they already have, they know how to recognize insert statements. So you can do the insert and then first. So first was this this tuple, and then insert was my command. And automatically that is done. So you can see in the same cell, I'm also committing. Oh, so one thing that if you're adding to a database that you have to do, you always have to commit your changes. And then I'm just closing the connection after that is done. So at this point, I actually have one row in my database. And let me actually bring the code up so I can see that. Here. Let me just do another version of that. Here. So this should be right. There we go. So you can see that in my database, I have the first row, and this came directly from my database. What I'm doing here, you can see that when I do the execute statement, this is by itself. From the cursor, I'm doing a fetch all to get, so let me actually just do this. So if I do cursor.fetch all, it becomes like, oh, I think because I had to do this earlier. Never mind, I'll demonstrate that later. But yeah, this is the method that you're going to do. The fetch all basically doesn't have the column names. And so I'm doing this list comprehension to get my column names. This is something I had to look up as well. I'll go into more detail on that later, but we're going to see how we can insert a lot of data at the same time. So same format, just multiple rows. So really quickly, we'll take a look at our data at this point. I'm just going to do the same thing but for everything. So now I have a list of 13 value tuples, and this is just all the data that I want to put in. And then same thing, instead of doing a cursor.execute, I'm doing a cursor.execute many. So that's really the only difference. I'm going to use the same insert statement, and instead of one 13 value tuple, I'm going to use the list of 13 value tuples. And execute many knows how to do that, knows how to read that. So really quickly running the cell, everything has been inserted here. And then just to query this really quickly, you'll see that I have all of my data in my table now. Of course, the first one is replicated because I had inserted one before. But yeah, this is all here. So one more thing to mention, if you realize you did something wrong in like the configuration of your table, or in like maybe like you forgot to get rid of null values, that is kind of why I have this here, where I can just drop the entire database and just recreate it. I will say in a lot of people's experience as well, when you're creating a database, it's very much like you figure out something is wrong and you're just gonna redo the whole thing. That's a very, very normal process, I will say. But yeah, any questions before I talk about the thing I want to talk about with like this cursor?
How we can read the data directly from the SQL server instead of turning it into a data frame? Is it possible or not?
Yeah, you definitely don't have to put it into a data frame. So let me just copy and paste this so I can. So now that I've done cursor.execute, cursor.fetchAll, cursor.fetchAll gives you that list of tuples. So this, you technically don't have to coerce into a data frame. If you do cursor.description, which is basically what I did here, cursor.description has this information. I honestly forget. I think it's literally doing like a dot describe maybe on all of this. I forget at the moment, but yeah, the cursor.execute itself is, yeah, you don't have to put into a data frame if you don't want to. Of course, it's the easiest form of like a table that we know how to work with in a Jupyter notebook. But yeah, if you don't need to put it into a data frame, you don't have to. Any other questions? All right. I will say this is very finicky. I think that it is valuable to work with AWS just so you have experience with that. But also it's definitely not a requirement for this project to work with SQL. I want everyone to remember that. Just wanted to show you all things that you could do. You could also not do this now. This material will be available for you to refer back to in the future. In terms of, I don't know what this was, but basically you can read in your data this way, or with like the cursor.execute, or if you remember from the study group that I did on SQL, you can actually use pd.read SQL. That's a method that you can also use to read in your data into your Jupyter notebook, just so that you all are aware. But yeah, that is putting data into SQL databases. Whichever method you choose, whether you do like this really easy method or whether you do, you know, this, I do think it is helpful to have some SQL component as part of your portfolio. Doesn't have to be through this project. Honestly, like if you want to just like set up some database to say that you have the experience doing that, and if you find like a better data set that, you know, has like multiple tables to do that for, you can definitely do that as like a separate thing, not for the capstone, but yeah. Cool. Any further questions?
Question about like, do you have any guidelines in terms of like how big should the database be? Like at what point do you split it into separate tables?
That's a good question. If you have like the reason why there are separate tables here is because that each table is literally different. So if you have just the same columns and in one table and it's very, very long, there is no limit to like, there is no guideline on how many rows your data table can or should have. This is in multiple tables just because like this is, I guess, like a sales database where you have different customers. So this is all the customers data. This is like the order data. So I could technically join this, probably not this specific one, but if I had the other tables, I could join all of that with each other, because it's not an efficient way to have these two tables information in the same table, if that makes sense. So yeah, if you find that all of your data exists efficiently in one table, that you don't have much redundancy, there's no reason to split it into multiple tables. Yeah, anything else? Cool. Well, if no one has any other questions about this, I did get a request to talk about pagination when it comes to like APIs or web scraping. So actually what I'm gonna do, I'm just gonna pull up like the study group notes that I had from before and talk about that because I think now that y'all have more information on or are more used to working with Jupyter Books than you were like 3 months ago, it'll make a little bit more sense. Hopefully it loads this one as well. I don't know if y'all have seen the GitHub dark mode. The GitHub dark mode is the only dark mode that I do not like. It's just awful contrasting colors. I don't know if anyone has any thoughts on that. All right, if this is not loading, let me just pull it up on my end.
Excuse me, Ish, before you start, I want to ask a question. Can we use some applications to do these for us? For example, for APIs, can we use Postman, or for web scraping, some other application like ParseHop or something like that?
Yeah, definitely. Postman is the one that basically verifies your JSON schema, I believe. Like not verifies, but it will break down your JSON schema so it's easier to read, if I'm not wrong, if I'm remembering correctly. So yeah, you can definitely use that to simplify your process. Because I believe, well, at least with Postman, I forget what was the other one that you mentioned.
The other one was ParseHop for web scraping.
Yeah, you can definitely use that to help you like figure out which element you want. But I believe like even if you're using those, you inevitably have to still code out your beautiful soup. All right, let's talk about this stuff then. So the idea of pagination is basically with both using APIs and web scraping, there are limits to how much data you can get. And so actually, let me run certain cells here so that it'll work. I know I need pandas, I need JSON, and let's see if there's anything else. Where's requests? Here we go. All right, so the example that I had before, and I guess I also need this. Oh, I guess I don't have my config file here. So let's not do this example. I know I have it here. All right, let's use this example then. Let me just import, I'll make sure I have all the imports that I need. All right, so I'm just gonna talk about it in terms of web scraping, but the same concept does apply for APIs. And I'll talk about the specific like offset part of APIs. So if y'all remember this example, pagination is just the process of putting multiple pages of data together. As you can see here, there's a total of 1,000 results, but this page only has 20. And so I'm gonna have to run the same scraping function on, was it 50? Yeah, 50 different pages. So pagination is just the process of putting that all together. Usually with pagination, you're gonna first figure out how to scrape one page of data. With this example, I figured out that scraping one page of data can be done with this function. And another thing to think about is how are you going to loop through the different pages? Sometimes you have a specific button on the page that you have to scrape and find like the URL for. So with this example, one possible thing to scrape is the URL for this button here in the next, which you can inspect and get here. Or you can figure out what are the changes in the URL when you go to the next page. So you can see here on page 1, if I click next, the URL, the 1 just changes to 2. The 2 changes to 3. And you can basically test this out here and there. Does it work for page 48? It does. Does it work all the way to page 50? Because I know that there are 50 pages. That works too. So those are the 2 things they have to keep track of. 1, how is the URL changing, especially, then this is for web scraping, how is the URL changing? And 2, figure out how to scrape 1 page first, because hopefully most websites are pretty consistent between their pages. So in this example, this is the function that I use to scrape 20 books off of 1 single page. If I run this function, or I just store this function really quickly, I've also figured out that all of the URLs, I can get them like this. So all I'm doing is I'm doing like the string format for all 50 URLs. So I have the 50 URLs here. And then all I need to do is run this same scrape function on 50 URLs, and then I have all the data. And this is the pagination process. So you can see here, what I'm doing here is I am getting all of, hold on, let me see. Yeah, so this allows me to, for URL and URLs, yeah. So this is looping through all the URLs, all 50 URLs, and adding the information to this list. And this is the pagination part. What do I not have here? All right, clean scrape. Let's run this. Okay, what do I not have first? It looks like I have to run everything. But yeah, any questions, or is anything like unclear at this point? Cool, there we go. Yep, so this is the process of pagination, just putting multiple pages of stuff together. And now you can see here, if I coerce into a data frame, I have all 10,000 rows. Yeah, any questions at this point regarding this?
I guess, could you show us how this applies with the offset and APIs?
Yep, that's what I was going to talk about next.
Okay, yeah, thank you.
All good. Yeah, so for APIs, it also kind of depends on the API itself, but most APIs will limit the number of results you get per query. For the New York Times, I believe that it is 20. So actually, it's been a while since I've been on the New York Times API. So let's just see. New York Times API. I'm going to log in real quick so I can put in my credentials. Oops. Hopefully this is right. Okay, so I can go to my apps. I'm just going to throw in my API key so it's there, but as you all know, you should not do that. So API key, I'm going to put it here. Okay, remember that you should not do this. Let me just make sure everything is run before I talk about it. Okay, well, we'll just see what kind of errors I get. All right, so with the New York Times API, and let me just grab the documentation real quick. Nope. And I use I think this is the movie reviews one. So I believe it should say somewhere that, and I was doing a search. There we go. So first you see that it should tell you that it only gives you 20. Anyways, maybe also through like you querying the API, you find out that every API call only gives you 20 results. This is where offset comes in. So offset comes in where if you get the first 20 results, if you set offset equal to 20, the next API query you do, you'll start at the 21st result, if that makes sense. So as an example, hopefully this will run. Let's see, this is offset equals to, let's not do offset for now. Okay. use this, do offset equal, get rid of the offset and put my API key. That was not my API key. Okay. So this hopefully should work. Nope. There we go. So this should work. These are the first 20 results. So here, there are basically 20 results. You can take my word for it. And then you can see that this first one was, what's the name of this one? Am I missing the name of the movie? Oh, Falling. Okay. So this one's called Falling. And by doing offset, and let me just add back in the offset parameter, offset equals 20. It's a different set of results. So this will be the next 20 results. And this is for finding Ohana. And every API does it slightly differently. Here it offsets by 20. So the number that you put here has to be a multiple of 20. Or actually, I think it works at like, let me see if 15 works too. Yeah, I guess this just means it'll start at result number 15 or result number 16. But yeah, the idea is because every query will give me back 20 results, I'm just going to increment this by 20 to get the next and the next 20 results. How you put this together, you would just have to write the function to do that. So in this, you see here that I have this function. Of course, this is not the best written function, but I'm just going to loop through a range of numbers. And what's going to happen here is I'm going to edit the offset with every loop. And with every offset, I'm just going to take n times 20 because I know I want to increment by 20. And all I'm doing here is I'm actually just putting all the results together into a list. So this is the process of pagination, the part that I'm putting additional results to an existing results list. And so when I run this, hopefully this works without me having to redo anything. So the way I wrote this function was such that you would get n times 20 reviews. So I got 80 reviews just by doing this. And again, I would say every API is slightly different, but every API should have some offset parameter. I know the ones I talked about yesterday, both, actually Twint, I'm not sure. I think Twint, you can just tell it how many you want. But Spotify's API has an offset. I said 1,000, but it's actually 50. I think 1,000 might have come from the number of queries that you can make per some time frame. But yeah, every API, most APIs has some offset parameter that allows you to get, more than just a set number of results. Any further questions on that?
So the offset is changing every time, right?
That's
you have to
right.
put in, it's like starting at 40, starting at 60. Okay.
Yep, that's right. So I remember I had to do this because for some reason, if I did offset equals to 0, it wasn't working. So therefore I did like, all right, if I started it at 0, I would just run the regular one. And then if it isn't 0, I would just do like the 20, 40, 60, 80, so on and so forth. Awesome. Any final questions?
How do we know the website that we are going to scrape is, for example, we can do that. We have the permission to do that because I still want to buy something from Amazon.
Yeah, that's a great question. Usually how you find out is you try and then it doesn't work, which I know is not a great answer, but it's hard to tell. I know like there's some way to figure out in like every website has like a robots.txt. I personally don't know too much about this, but I think every website has a robots.txt that you can like find out what is blocked. So yeah, that is something that you can do. I've never really used this. This is something that I found out from other people. But yeah, there are a couple websites that I like try to scrape. and then they throw me an error, and it's some sort of like authorization error, or like I know I found some like funny Easter eggs in trying to scrape some websites, but yeah, it's hard to say.
Okay, thank you.
You're welcome. Anything else? Yeah, I believe if you go to like any website and then you do like robots.txt. So for example, let's just go to like scikit-learn's website. And if I do like, I forget if it's here. No, not here. So it must be back here maybe? Oh, no, that's wrong. Yeah, I personally don't use this method too much. I guess not, but yeah, I guess not every website has this. But this is one method that I've heard of that can sometimes tell you whether you can scrape or not. But yeah.
For the things that it says disallow, it means that you can't scrape those items?
I think if they won't allow specific kinds of, honestly, I'm not too sure. I will only speculate that I think it won't allow you to, it won't allow you to scrape anything. Yep, looks like they won't allow you to scrape anything that has like a slash any of this, I guess. Yeah, let's just see, since this is a BuzzFeed example, let's just see if this works for us. There we go. Yep, so it looks like you can't, I'm
So
guessing you can't
literally
scrape
nothing.
that. Yeah, I mean, sometimes, I know this is like a crawl delay. So I know that some websites, they actually have limits to how many times an IP address can ping their website. So there are some websites that like after 5 API calls or 5 tries to web scrape, they stop you. And then you just have to like wait a little while. I forget how you find that information, honestly, but I'm guessing it's something to do with like this 120 number, maybe this 4 number. But yeah. Yeah, I personally am not super familiar with this part of websites.
Thank you.
You're welcome. If anyone else knows, let me know. But yeah, hopefully today was helpful. Again, happy to like take requests on anything that you all are needing a refresher on. Just a reminder, tomorrow I'm going to be talking about Jupyter Dash, which is actually pretty cool. If you all want to like start looking it up, it's really neat. Jupyter Dash, we're going to just build like a really, really simple dashboard within your Jupyter notebook. So you can see, hopefully this GIF will run faster. Yeah, you can build something like that with like drop-down menus, and yeah, that's what we're gonna look at building tomorrow. There are a lot of components to it, so I'm not sure if we'll talk about all of it. I can also like break it up into several different parts, because I will say that if you want to have a dashboard like this, your plots should be written in Plotly or Plotly Express. So if any of you are getting started with your visualizations or your EDA, consider, if you want to have a dashboard like this, the easiest way to port that information into a dashboard is by doing all of your plots in Plotly. All right, then, if there's nothing else, I will talk. Oh, yes.
I have a quick random GitHub question.
Sure.
For like a group project, I think you at one point you showed us how to copy and have it so it's under our name instead of our partner's name. Can
Yes.
you refresh my memory real quick?
Absolutely. Very, very quickly. If imagine this is your group project, all you have to do is fork it over to your own repo. And then you're good. Just click the fork button, and then you'll see that there will be a version of the repo that has your own username, and then you're all set.
Got it. Thanks.
You're welcome. Yeah, I will say, as you know, as you guys are getting your career services started, they will ask you to do that. So all of your projects should have your own username in the URL rather than, you know, your partner's username. One other pro of that is that in the future, if you want to make your own changes to a project, you can do that independently of your project partner. Might be a pro, might be a con, I don't know, but yeah, you'll have that ability. All right then. If there's nothing else, I will talk to you all tomorrow. We'll create some really simple dashboards. I'll potentially build on that in a couple sessions next week. But yeah, don't forget, you have 6 more days to pitch your project to me. I've been getting some really cool ideas, so excited to hear more. All right then, have a good rest of your day, everybody. Bye.